In this phase of our lesson, what we want to do is we want to simplify radicals. What we want to do is that we want to be able to identify a perfect square. We want to identify a square number that is a factor of these. And then from there, we're able to handle what we have. Let us look on some square numbers. Square numbers, I'm going to list just a few of the square numbers. So the square numbers are as follows. So 1 is a square number, on and on to infinity. Remember, 1 times, so this is 1 square, this is 2 square, this is 3 square, this one is 4 square, and it goes on. Okay? So what we want to do is to identify the largest square number that is a factor of our radicand, right? So the radicand is the number underneath our square root, right? So let us rewrite this. So the root of 25 times 3, right? So 25 times 3 is 75. From this, we could split this further to the root of 25 times the root of 3. Remember that 25 is a square number. So because 25 is a square number, I'm now able to take the square root of 25, which is 5, and then root 3. 3 is not a square number, so we have to leave this. So this is saying to us that the root of 75, when simplified, is 5 root 3. Let's take a look at number 2. For number 2, we have a square number, which is 16. Actually have the square root of 16, which is as 4. Let's take a look at number 3. This one is quite simple. Square root of 36 is just 6. The square root of 64 is 8. Now for number 5 though, for number 5, we're looking at 80. We can rewrite 80 by using 16. So we can write this as 16 times 5. Then we're going to split this using that product rule for the radicands. So it's going to be the root of 16 times the root of 5. Now remember that 16 is a square number. 4 16, which means the square root of 16 is 4. And then we have our root 5. Now, there is another way we could have worked this out as well, right? Let's take a look at a second way to do this. Now, for the root of 80, we have two numbers that could have worked. We have 4, we have 16. The response that we just did, we use 16. So I'm going to use 4 here, but I'm going to show you why I'll choose 16 rather than 4. We could have written the root of 80 as 4 times 20. This goes further, would be the root of 4 times the root of 20. With this said, the square root of 4 is 2, and then we have our root 20. But we do realize that the root of 20 can actually be broken down to more. So let's take a look. We have that 2 there, but the root 20 could be written as root 4, root 5. Remember the square root of 4 is 2, so we'll have 2 times 2, then root 5. 2 times 2 gives us 4, and then root 5. As you could see, we would have gotten the same answer. But because we did not use the largest square number, that is a factor of 80, we had a longer process, right? So my suggestion to you is that when you find more than one square number that's a factor of our radicand, we need to use the largest one, and it works quicker for us. But using the other one is correct as well, but it takes a little bit long. Let's go back to the drawing board. We're looking at number 6. Number 6 says the root of 30. When we look at the root of 30, if we think of the square numbers, I have numbers to try, okay? But I'm not going to try any number larger than 30. So I only have 4, 9, 16, and 25. to see which one of these could actually go into 30 without a remainder. 4 cannot go into 30 without a remainder. 9 cannot, 16 cannot, 25 cannot. So what it means is that this is in its lowest form in terms of radical form. That cannot be broken down. So the root of 30 is okay as is. That's the lowest we could go. Let's take a look at number 7. For number 7, what we have is the root of 8. We can break the root of 8 by using the square number 4. 4 2's gives us 8, which means that we could go further. We could say the root 4 times root 2. The root of 4 is 2, and then 2 is not a square number, so we're going to have to leave it as is. So the answer is 2 root 2. What this means is that the root of 8 is the same as 2 root 2. For number 8, 18. So we have the root of 18. We could rewrite this as the root of 9 times 2, because 9 2's gives us 18. And not only that, 9 is a square number. Remember that we only need to identify one square number and then make sure that that square number is the largest one possible. The next step is that we have the root of 9 times the root of 2. Then what is the root of 9? 3. And then 2 is not a square number, so we leave this as is. Conclusion, the root of 18, when simplified, is 3 root 2. For number 9, we want to look at the root of 32. What's the largest square number that could work? 16. So we're going to use 16 times 2. From this, we're going to have the root of 16 times the root of 2. Remember that 16 is a square number. 4 4's gives 16. So the square root of 16 will give us 4 root 2. Remember that 2 is not a square number. So our final response is the root of 32, when simplified, is 4 root 2. Let's take a look at question 10. Question 10 has the root of 12. So the root of 12 can be rewritten as the root of 4 times 3. Then we could split this as root 4 times root 3. Remember that 4 is a square number. So the root of 4 is actually 2. 3 is not a square number, so we leave it here. So the response is the root of 12 is actually 2 root 3. For number 11, we have root of 8 again, but we just did it here. So we're going to skip that one. So number 12 actually says root 8, root of 108. Now for the square number that I'm looking for, I'm going to use 36. 36 times 3 gives me 108. From this, I'm going to have the root of 36 times the root of 3. Remember that 36 is a square number. 6 square. So what we're going to do is taking the square root of 36, I'll get 6. 3 is not a square number, so I put it back. So the root of 108, when simplified, is 6 root 3. Right, let's do number 13. For number 13, I have the root of 125. 25 is a good number to use. So this is going to give me 25 times 5. Right? So 25 times 5, which means that I'm able to split this into the root of 25 times the root of 5. 25 is actually a square number. So the root of 25 is 5. But remember that the number 5 is not a square number, so I have to leave it under the root sign. So in conclusion, we could say that the root of 125 when simplified is actually 5 root 5. Let's take a look at number 17. For number 17, what we're looking at is the root of 45. The root of 45, the largest square number that is a factor of 45 is 9. So I could rewrite the root of 45 as 9 times 5. From here, we could split this further to the root of 9 times the root of 5. Again, 9 is actually a square number, which means the root of 9 will give me 3, and then 5 is not a square number, I put it back. In conclusion, the root of 45 is equal to 3 root 5. We're going to stop there for today.